warahmatullahi wabarakatuh. My name is Muhammad Akili. Today, I will be present about the paper review on the 3D seismic reflection imaging of fracture zones in crystalline rock. The important thing about this paper is to review all the process, and also the most highlight one is about the 3D binning process. So next for the test, the introduction is the island of Avro, which is the site that focus on in this area is the island of Avro, which located at the southeast region, which is the part of Phenoscandian shield, which mainly composed of Precambrian crystalline rock, and the dominant rock type on Avro is medium grain, which the grey red granite is the main rock type in Avro, in the island of Avro, with with many type of pegmatitic and apatite dikes from youngest rock on the Avro side. This is the test site and seismic reflection profiling in Avro area, which is the focus study. Next, how they acquire the data. First of all, the 3D data acquisition is from the station layout was designed to record 2D seismic reflection data along two crossing profile, which in 1850 and 1060 meter long, which is the 2D data, and the 3D data is about the within 400 times 400 meter, which in visible array. As you can see, the 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 seismic data, the acquired seismic data in the area. First is line 3 and line 4, which is the 2D data, and the array is show the 3D data seismic located. And within the roughly the orientation of the array is south north, and the space is about 10 hertz geoforce. The space is 20 meter, and the geoforce hertz is 10, and with the south north direction, and 10 receiver for the 2D, 10 receiver lines, and 40 meter in west east direction, and 20 receiver line respectively yielding 200 receiver position. As you can see, the 20 receiver line is show the array, the 3D data acquisition, but the receiver is for the 2D data acquisition. Okay, for the 3D data is the processing technique. This is the main processing technique, which is conducted by the the paper publishes, which is the main survey parameter. As you can see, this is a parameter for 2D profiles 934 with dynamic, which is 2D profiles, and receiver array, which is for 3D profiles. The dynamic charge is 15 gram and for each, and charge depth is 0.9 for each also. Short spacing is same for 10 meter with geophone type with 20 Hz for the 2D and 6 times 10 Hz which for 3D. Geophone spacing is 10 meter and 20 times 40 meter for the 3D. Channels is 100 to 232 for 2D profiles and 100 for 3D profiles. The sample rate is 0.5 for the 2D and 1 meter for the 3D. For the main processing steps is, for 1 is geometry trace editing, 2 is a wave automation, 4 is geometry spreading, surface coverage sparking, band pass filter, and phase equalization with the mesh filter, and direct shortwave removal, which is linear processing. And 9 is stop mute, 3D binding, residual static correction, NMO, 3D DMO, and also FK filter deconvolution, trace, and interpolation with the time depth convention. For next, for the next is 3D common midpoint binding, which is focused on the processing part, which is, as you can see, the formula we use is in binding process is Vmin over 4 frequency max sin alpha max, which is Vmin is for the velocity in minimum, which are 4 frequency in the maximum accommodative, and also the alpha max is the common midpoint, which is used by Yilmaz 2001. They take from Yilmaz 2001 to compute all the data. As you can see, the acquisition for the common point binding is about by the regular offset and azimuth distribution in the place. As you can see, the regularity of the data acquisition you must use this binding to produce an accurate data. And also it also determines the azimuth distribution of the place. Next is about the subsurface coverage and flexible binning. The CMP bin size was increased locally by trace for an area of 7.5 to 7.5 meter around the CMP bin was shared between adjacent bin. And also it increased the CMP4 distribution. As you can see on the screen, the picture show the folding of the binning in A to the E, the distribution of the fold, and also the flexible increase, binning increase the maximum fold from 39 to 75, which approximate with the average of the fold change from 5 to 9. And also the trace sharing result, the increase of about 10%, which approximately of 16,000 bins. In clearly is shown in this picture. Also the most important, the subsurface coverage, and we jump to the subsurface coverage and the flexible binning. As you can see, figure C and D shows the two sections of the extracted of 3D volume after we apply the binning. As you can see, there is a B2 and E on the more highlighted on E part. As you can see, it's not shown in C, but it obviously show on D. Then the DMO correction is applied. The DMO correction apply the pre-stack and post-stack migration, which reinforce the reflected signal by constructive interference, which the overlapping operators destructive interference, which mean by the pre-stack is overlap which is other to reduce the destructive interference between the two waves to seismic trace. For the result and discussion, this is the result and the final result of the paper review, which is the final migrate depth converted 3D seismic image, which reveal the dipping reflected in the upper 800 meter. As you can see for the both of the picture, you can see the dipping part of the seismic reflected, the dipping part of the wave is on the upper 800 meter of the object space, and the feature is more shown in 3D figures, which is on the box side. On the left side, more shown in the different reflectors, which is B1 and B2, and the sub-horizontal event of F1, F2, F E1, E2, and E3. As you can see, the reflection point will complete for every source and receiver pair. We've been in 7.5, 7.5 meter wide, and the grayscale indicates foot of beam, and the line gray shows extent of reflector 1, as you can see from the picture, and the grayscale applies to A and C, A to C, which indicates number of reflection point in 7.5 and 7.5 meter wide beams. As a result of the, as a conclusion, based on the result of the source and receiver differential, the CMP are distributed over an irregular, as you can see for the data on the 3D data acquisition, and also it is also roughly cross-shaped area with short offset of 400 meter trace concentrated in the central part of the survey site, which you can see on the data 3D data acquisition. For the reducing the matters, we using the flexible binning scheme to reduce the fault variation of this data. That is for me. Thank you.